Get started. Again, thanks for all for being here. We're really excited to share this sort of more informational webinar on Pinecone. So getting started, optimizing your experience, and some advanced tips and tricks, as well as some other goodies that I'll go over and Kevin and Greg will go into more. As always, this recording and the deck and demo will be shared with you after this, so that if you would like to revisit it, share it with colleagues, you are welcome to. And please place any questions in the Q&A box at the bottom of your screen, not in the chat box, so that they can be answered and recorded. And without further ado, I'm going to introduce Greg, who is our VP of Marketing, and Kevin, our Customer Success Engineer, who will be taking you through what Pinecone is, how to optimize your experience using it, and how to get started. So this is our agenda. We'll have an intro to vector search and databases, what Pinecone actually is, embeddings and how to get them, since you need embeddings to be able to use a vector database. Launch your first vector database. So this is going to be kind of a walkthrough equivalent of our quick start guide, which you can find online. And you can use that as well in your future endeavors with Pinecone. We'll do a walkthrough of a real use case and the demo code for which will be available to you later on, so you can practice yourself. You'll learn how to scale your own vector database and some advanced tips and best practices for your Pinecone use, as well as, of course, Q&A at the end, as always. So with that, I will pass it on over to Greg, who will enlighten us on vector search and vector databases.
Hey everyone, good to see you all here. I expect most of you are familiar with vector search and vector databases, so we'll cover this for just a few minutes, just to be sure, and also to set the context for the deeper dive you'll see later. In a nutshell, vector search takes advantage of the fact that we now have new technologies to represent any kind of data in a very meaningful, semantically rich way that machines can work with. And that format is called a vector embedding. And you generate vector embeddings with embedding models. You can visualize this with a 3D plot, like you see on the left, where different kinds of data, in this case, single words, are placed in that vector space based on their meaning. So here we see days of the week are sort of clumped together. And so if we do a search, a nearest neighbor search of, something like Wednesday, you look on the right, the nearest neighbors to that should be other days of the week. And you can imagine this extending to entire sentences, entire documents, and even non-text data like images, video, audio, and so on. Vector databases allow us to do this at a very large scale, very quickly. So it's easy to search through 7 days of the week, but if you're searching through a document catalog of millions, hundreds of millions, or billions of documents, very computationally intensive, very difficult to do. And if you have a system like this in production, you'll probably also want to manage those embeddings. You'll need to update the catalog, delete things, add things. You'll probably need to scale it to meet growing demand and a growing index. You'll want to filter your search results based on metadata, like let's say I'm searching for Friday, but I'm looking for movies and not days of the week. I would want to see the movie Friday with, I think is it Ice Cube? Yeah, I think Ice Cube. And that's what a database lets you do. Basically take this new capability into production. Okay, next slide. So Pinecone is this vector database. It makes it easy to add vector search into production and just manage it without any infrastructure hassles, without having to deal with, without having to be an expert data scientist or DevOps engineer. Usually it sits alongside embedding models. You have to generate embeddings before you can index them in a vector database. And both queries from your application have to pass through the embedding model, and your catalog data has to pass through that model. But once you have things indexed in Pinecone, you can query straight from your application and get back the results you need. Okay, next slide. Okay, so real quick, most people here might have vector embeddings already. In case you don't, several ways of getting them. You can use APIs like OpenAI, Cohere, and Hugging Face to generate, to turn your data into vector embeddings. You can get help from consultancies. We have partners like Strong and SmartCat that work with large companies, actually companies of all sizes, developing embedding models for them. You can ask your data science colleagues. We sometimes come across engineering teams who ask about vector embeddings or say they don't have them. Then they find out from their data scientists that actually it's easy for them to get those embeddings. If you want to endeavor on this journey yourself and learn how embedding models are created and fine-tuned and so on, we have lots of resources, pinecone.io/learn. Okay. Vector search with Pinecone is fast, fresh, and filtered. So I mentioned before, this is something that's unique about Pinecone. If you're doing vector search with Pinecone, you're going to get low latencies at large scale. You're going to get a live index, meaning the index is always up to date with your to match your catalog. And for some use cases, this is critical, where you don't want to search outdated or missing, no longer relevant results to your users. And finally, it's filtered. You can combine metadata filters with nearest neighbor searches to get movies when you want movies and not days of the week and things like that. Okay, next slide. All right, and finally, it is a fully managed service, and so makes it very easy to use. Just if you can use an API, you can use Pinecone. You only pay for what you use. You don't have to worry about the infrastructure. We run on AWS and GCP. We set it up for you, make it easy to scale. There's nothing to manage, and we are SOC 2 compliant and help you meet all these regulatory requirements fairly easily. Okay. Maybe you picked up something new in that, but now it's time for action, and I'll pass it over to Kevin.
Okay, thanks, Greg. Appreciate it. Lots of good information there. So yes, the remainder of, or at least the demo portion of this, is going to be literally from scratch, no smoke and mirrors. It's we're going to create, in fact, the next slide, I'll show you what we're going to create. But ultimately, what we're going to do today is we're going to use Pinecone to identify duplicate documents. Okay. So today we are going to literally set up our Pinecone account. We're going to download the Pinecone GitHub examples, which are a number of notebooks and deep examples, both Python code wise, as well as data science concepts. So a lot of free knowledge there and really good code examples to be able to get started with. Particularly today, we're going to be using the deduplication example that's already in the GitHub, and it's also outlined in our examples section of our website. We're also going to prepare a Python 3 virtual environment, install Jupyter, run Jupyter, and then we're actually going to make a switch over to Google Vertex AI to run the notebook, and I'll tell you why that's an advantage a little bit later. And then finally, we'll review what we learned. Okay, so for the account setup and the Pinecone console, so the idea, of course, first is we need an actual Pinecone account. But before I go into the actual console, I want to give you some high-level concepts of what does the anatomy of a Pinecone account look like. What we're going to be creating today is an index with one additional replica So if we start at the top, as after we create our Pinecone account, we have a default project that is within our space to work with. The project itself will have definitions for which region it's in. So if it's in GCP versus AWS, if it's East versus West, and it will also contain a unique API key for that project, which will be which gives you the ability to do all of your CRUD transactions, create, read, update, and delete your index information. And then finally, there's a way here, the maximum pod count allows you to restrict by project how many pods someone can actually generate within an index. And we'll get a little deeper into that. So what we're looking at here is what would be considered 2 pods, 2 replicas. And so the first 2 pods are literally 2 Kubernetes pods within whichever region that the project specifies. The data is evenly distributed across those pods. And then in our case here, we added a replica, which is an exact copy of the original index, thereby bringing us to a count of 4 pods. And in this case, I chose P1 pods, which are performance optimized, to be able to give you the fastest QPS in addition to the replication. P1 pods can hold about 1 million vectors at about a 768 dimension, give or take a little bit of nuance with metadata, depending on the cardinality of your metadata and how much metadata you have. We can always assist you in helping to scale to get that perfect balance between speed and cost effectiveness. So we can evaluate your data and actually come up with that formula with you. So that's kind of high level what the Pinecone account actually looks like. So let's go into the console itself. But first, let me go ahead and let's walk through the GitHub in this case first. The GitHub is our repository. It's a public repository that has all of our notebook examples. And they also have similar examples on the website itself with actual walkthroughs of the code. And in many cases, videos that are literally walking through both the database, the data science concepts, as well as the actual code itself. So in our case today, we're going to go ahead and go to the GitHub repository. And in this case, we see all of the notebooks that are here. In our case today, we're going to go ahead and focus in on the deduplication notebook. And we can go ahead and grab that. Now, you have a couple of options here. If we go back out to the examples level here and we go to code, if you already use GitHub, great. You have your own either GitHub CLI or you have GitHub Desktop. Or if you don't have either one of those and you just want to download the entire set of notebooks, you can download a zip file here, which I've already done. So that's in my download folder, and I'm going to go ahead and I've already extracted that folder. So let's now go back into the actual console. When we go to create an account, it's your typical account. It gives you a couple of different ways to authenticate and to verify. One, of course, is GitHub. You can use your GitHub account, your Gmail account, or any other email account, and it'll essentially send you a code verification. And the next screen after you continue here will ask for that code, and then it will present. In fact, I'm going to log into my own starter account. And we see the live console here. Once you've created your account, you have a default project with your name on it. You can have multiple projects. And however, with the starter plan, of course, the one caveat to that is you're allowed 1 P1 pod, which will give you that ability to have up to 1 million vectors within a 768 dimension, for example. And in our case, if I click this, we have now gone into our project, but there are no indexes yet. So there's no default indexes. We haven't spun up any pods, and we haven't incurred any cost. Down the left-hand side, your project information is here. So you have your API keys, and I'll go ahead and show this one. And so now you see my API key, and you could technically spin up a pod in my index or create an index right now and start uploading data using that API key. One thing to note here is you can always rotate these keys. So if you're concerned about permissions or access, you can always rotate the key here, put in the name of the index, and then it will rotate the key. And now that key is different. Down below here, we have some example data. So you can, this is really useful just to get an idea of what data might look like from a vector standpoint, from a query standpoint, and actually creating it. You could actually fire this off and create a sample index within your account. And I'm going to go ahead and do that. If we go back up to the index level, we'll actually see the index being created. And it's initializing currently, so it's literally spinning up a Kubernetes pod to prepare for this index. In this case, it has 1,000 dimensions. It's a P1 performance optimized pod. And I want to show you a few things down below here. So first we have index info. So we can see how many vectors are in our index at any given time. And then one thing I want to point out, just about everywhere I click here, there's going to be a show curl command. So you have constant curl commands. In fact, you can even show the API key if you really want to, if you want to do your copy and paste out to your command line to be able to do these types of things. And same for the CRUD operations below here. So we have upserts, updates, fetch, queries, and delete. And I want to do a sample query just to give you an idea of, as you're developing, what you can do. So right now I don't have a query file to upload, but I'm going to go to the JSON editor, and it actually generates kind of a generic query to start with, and I'm actually going to run that query. So now we see an actual example of a JSON response, which contains our, in this case, our vectors and our metadata, along with the entire JSON response, along with our top K number of results. So this allows us to kind of see what is that JSON output as we're doing our development and you're integrating this with your own applications. And so this is a helpful tool as kind of a reference here. Once again, we also have a show curl command. And this will also give you kind of a curl command on running that query, or in this case, right, we're running this query with the vector in this case. So lots of good little references there as you're doing development work. And then finally, the last thing I want to show is the ability to have collaborators. So there are probably developers within your organization who may not have or own a Pinecone account. However, you can invite users to the account, and that will give them access to the API keys, and they can contribute to the development of your index. And then finally, down below here, documents. I'm actually going to go to the docs page. I want to show you two of my favorite places here. The example labs here, which was what I was referring to earlier, where we have all of our examples and walkthroughs. So on the right-hand side here, we have a semantic text example, literally goes through all of the code and explains what's happening. And then back on the previous page, you can view source, which will take you to the GitHub link. And then finally, if you immediately want to run this example, you can actually open this in Google Colab, and it'll go straight to a Jupyter notebook with the code, and you can literally run the example there as well. Good stuff. The other thing I wanted to show is our API, which we kind of segment into vector operations, which are all of your CRUD operations on your actual vectors for your index. And then your index operations, being able to create, describe, delete, scale, all of that is under your index operations. Back within the console, there was a couple other things here under our index here. One thing we didn't see was our metrics section. So right now we have the ability to look at a couple of things here. We saw some, there's some green and blue here, which represents queries and upserts. And then we also have some gray here, which represents the describe index API call. So as you're starting to ingest, as you're starting to query and look at loads and monitoring, this is where you can see some of that. And when we do the actual notebook run, we'll actually try to run back in here and capture that happening live. Okay, one last thing I'll mention about all of these, what you're looking at on the request types here, these are all API calls. And speaking of those APIs, you can use things like Postman, you can use REST APIs within whatever code you're running, whether it's Python, whether it's another application that just makes individual REST calls. And all of the activity that you can do in the UI can also be accomplished using the API. Okay, so let's go ahead into that takes care of GitHub. And now we're ready to go ahead and start coding. So I'm going to have a simple command line here open. And we're going to go ahead and begin setting this up as if we've never used it before, as if we've never run the code before, and go ahead and set up the environment. In this case, I'm using an Apple MacBook Pro with an M1 CPU architecture. Python is already installed in the operating system, and if you need help installing Python from scratch, of course, you can go to python.org and get some instructions there, depending on your operating system and your requirements. So the first thing we're going to do is update pip, and pip is the package manager for Python, and we're going to go ahead and run some commands here. We're going to say pip install U for update pip. So this is actually updating the package installer on my local machine, on my local Python. And now we're ready. In fact, I've run this before, so it says that it's already satisfied. Taking a moment, I'm going to go ahead and skip that because it's already done. And the other command that you might need to run depending on your environment is to actually install the virtual environment. So this is the command here, python 3-m pip install -user virtual environment. Again, it's already satisfied. This is already installed already into my environment. Okay, so let me clear this and let's actually create the virtual environment. And why do we need a virtual environment for Python? Essentially, this creates a sandbox for you to be able to install a bunch of packages without interfering with other packages. And that way you don't have collisions and other issues, and you can kind of segment or sandbox your Python environment. Oops, sorry, wrong command. Clear this. So I need to create the virtual environment. So it's python 3-m, meaning that I'm running the venv module. And in my case, I'm creating this path in my file system to my volume add link. And then I'm going to name the environment Pinecone. So notice on the left-hand side of my command line, it says base. And so right now I'm actually, if I say which Python, I'm actually running Anaconda as well. So that's where actually my virtual environment for my base is right now. So let's switch over to our new Pinecone virtual environment. And the command for that is source, and then the path, and then we actually add two more items, bin and activate, and that will give us Pinecone on the left-hand side of our command line. So now we've essentially switched to that environment, and we want to do a couple of things here. So the first thing I'm going to do again is I'm going to upgrade pip. Install pip. So this will bring the virtual environment up to the same version of pip that was in my main environment. Should go to 22.2. Go ahead and start my command line over here. It looks like I'm having issues. Dangers of a live environment. This one. And I needed to run my source again to make sure I'm in Pinecone. Okay, so let's see. I'm going to do a pip install Jupyter in this case, see if this installs properly. And there's always an alternative plan B here if this continues to give me some trouble. Okay. So what I'm going to do at this point is I am actually going to deactivate my environment and go back to my base. And I'm going to actually say Jupyter Notebook. Okay. Once we run that and you have Jupyter installed in your virtual environment, then you can run Jupyter Notebook as well. So the commands were essentially updating pip and then pip install Jupyter. And then you can do Jupyter Notebook, which will bring us here. And in my case, I already mentioned that I downloaded the GitHub files earlier and I extracted those and they're currently sitting in my download folder. So this is the same file structure that is on the GitHub repository. And we're going to focus in on the deduplication example. And we're going to go ahead and open the notebook here. Okay, so at this point, you do have a complete Jupyter notebook running locally, presumably in your Python virtual environment. And you can actually run the entire notebook now. However, I'm going to mention a couple of advanced ideas here so that you can, there's nothing wrong with running the notebook here, but you're going to notice some latency and some speed issues, especially when we get into downloading files, installing the dependencies, and then being able to do the upserts. So one thing I'm going to recommend is we actually go over to what's called, in my case, Google Vertex AI. Google Vertex AI is a cloud-based Jupyter notebook with a lot of those dependencies already installed. And we're going to take that exact same notebook and actually run it from here. It's going to be a little bit faster, actually significantly faster than running it from your local. And then I've made a couple of changes. If you were to download the example right now, there's a couple of things that you'll see different. First, I'm taking advantage of our Python client gRPC, which is much faster than our standard Python client. And then one other thing here to point out, of course, as you set up your example notebook, you're going to have to set the API key here. So in the section where the initialize Pinecone index is, we go ahead and replace the API key with our actual API key. And if you're wondering, how do I know what my environment is? That's back in the console at the project level. And in fact, I'm going to switch over to my other account here in a moment, but here is the environment that you can use as the parameter when you do your setup. So I'm actually going to switch over to my other account because I actually need the ability to scale and perform that replication. And so I'm going to switch to my other account. And in this case, I have an enterprise dedicated plan and I'm in the same environment. Great, cool. And then when I go into my project, here's my API key. And so remember, that's what we need to actually copy to our Jupyter notebook. And that will allow us to get the Jupyter Notebook talking and being able to create the index and upsert the data. Okay, so now we're actually ready to run this notebook, and I'm not going to go through all of the detail on the notebook itself. However, what I do want to point out is, why did I use Google Vertex AI? First, the Jupyter Notebook itself is in the same region as my Pinecone index will be. This will give me much faster download speeds as I'm installing dependencies, as I'm downloading sample data for the notebook, and then upserting speed to Pinecone, as well as, of course, it gives you the collaboration abilities. Now, Google Vertex AI is not the only cloud Jupyter-based platform. You have Google Colab, you have SageMaker on AWS, and a number of other tools out there that you can make use of. Most of our example notebooks, like I mentioned, will drop you into a Google Colab notebook, which is cheap. And however, what I'm using here with Google Vertex AI, there's an actual good sized virtual machine behind the scenes running Jupyter. So I have more memory, I have more CPU, and naturally it's an advantage to run that notebook. So before we run the actual example, let's talk about what it does. So today's talk, of course, is not deep into the data science side of the notebook, but what this will actually do is it installs those initial dependencies. It loads example data files. It creates the Pinecone index, upserts the data to Pinecone, generates a test set of queries, vectorizes those queries, and then it sends those queries, gets the results back, and then there's an evaluation of the results to see how accurate the prediction was, whether or not they were considered duplicate documents. There's an entire walkthrough of this code and more explanation in the download link here, or the hyperlink. Okay, so let's go. Okay, so now I'm back in my Google Vertex, and I'm going to go ahead and go to my run, and I'm actually going to run the whole notebook. Just about all of our examples, they're, other than adding your API keys and setting those variables, those are really most of the prerequisites. You normally, once you make those changes, you can run the whole notebook. So right now the notebook is running, and if I scroll down to find the active cell that is actually running, is initializing our Pinecone index right now. So let's hop over to the Pinecone. Let's go back to our indexes, and now we see the deduplication index being spawned, and it is being initialized. It'll take a couple of moments. It needs to generate the 4 pods, and we should see this turn to green. There it is. And now we can actually go into the index, and we see much of the same sections that we did before. We have the index. We see vectors coming right now. So vectors are being loaded by the notebook. And then we can actually look at metrics as well. So let's look at some metrics as they start to get populated. Metrics are shipped out every few seconds. And we should start to see some, there we go. So this is a way that we can monitor, in this case, the green are upserts. And then right after, in the notebook, after it does the actual upserts, it's already done the upserts. And now it actually fires 209 queries. Those 209 queries are already done. We should be able to refresh this and see a blue line coming here in a moment that will represent those queries. And then finally, actually the notebook just finished. So it retrieved all those queries, and now it runs a series of activities to evaluate the accuracy of the predictions. And if we go down to the bottom, we can see here's the actual vector IDs and the metadata that was associated with those vector IDs, and then a scoring mechanism to see how close they were, and then whether or not our prediction was correct. So if we scroll further past this, We look at all predictions. In this case, all predictions were 100% correct as to with our test set. And we look at the different types of, some of them were actual duplicates, some were absolutely unique, and then some were possible duplicates. And then in the very last line of the notebook, there's almost always in our examples, there's a delete index. And so if we go back to the console one more time, go to index here, it disappears and it's gone. The main reason for that is in case when you are on your standard plan, you are on your enterprise level plan. If you spin up an index just to run this example and you want to get rid of that index to save cost, that will get rid of the index and thereby get rid of the pods, and therefore you won't have any more spend on those that example. Okay, so that's the example. And so let's talk about a couple of things that as you're planning your deployment, as you're trying to decide what scale you need, what type of pods you need, what level of SLAs you need, all of those are considerations here. But here are some tips, advanced tips for your development process. So first, my recommendation of going to a cloud service for your Jupyter notebook, that will geographically locate your notebooks to as close to Pinecone as possible, which will give you the best speeds. The other is your application. So your ancillary applications, maybe they're web servers, maybe there are other databases, maybe there are other mobile applications or other applications that need to be close to Pinecone. So the same principle applies. The closer you can get them geographically, the better off you are. And then finally, from a pure programming standpoint, reuse your connections within your code, reuse the same pinecone.index, and then that way you'll have the most efficient ability there. And then we also have some limits that are here. There's a link down below here for the same content that's on this page. And there are some known limits currently that you can decide. So maximum vector dimensionality is 20,000, which is huge. And then max size for upsert per request is 2 megabytes. So when you're trying to figure out what's the magic number of batch size for upserts, that's where the 2 megabytes comes into play. And then there's a couple other tips there as far as what you can and can't do there. Okay, so to wrap up the demonstration, we showed you how to create your account. We looked at the GitHub repository, which has just a plethora of free code and principles and use cases that you can compare to your use case to see how they stack up. And then, of course, again, just to mention one more time, in our example section and our learn section of our website, we have a lot of videos, a lot of examples, a lot of code to be able to help you get started. Finally, we talked a little bit about the Python virtual environment, setting up Jupyter, considering Jupyter in a cloud scenario. We looked at some monitoring and metrics while we were upserting and querying. And then we've talked a little bit about growth and scale. Ton of resources that we'll include in the slide deck, of course, and we'll include the link of this recording as well. To get your free API key, again, it's app.pinecone.io, and you can get your free account, start using it. There's no other restrictions on that other than you get one single P1 instance that's in the US East on US West on GCP. Okay, so I'm going to turn the microphone back over to Sophie, and we can go ahead and start our Q&A.
Thank you so much, Kevin and Greg. That was fantastic, and I hope folks had have a little more knowledge now of Pinecone and of vector databases than they did coming in, if you had some and are now feeling a little more confident, if you didn't have any to start with. Feel free to unmute yourself and ask questions, or go ahead and place them in the Q&A box in the chat below. So there's in the bottom panel of your Zoom screen, there's a little box on the right that says Q&A. Please put any questions you have in there. And there aren't, now there is one. Perfect. I'll read it out loud. And then Kevin or Greg, feel free to answer. My application's backend is Golang. I'd like to use the gRPC interface to Pinecone. I see no documentation for that. Where can I learn what I need to use?
Kevin, I'll let you take that, and also I'll ask a follow-up question, which is, is Python required? Do people have to set up the Python environments and all that to use Pinecone? You're muted, Kevin.
Thank you. So the Golang, we do have a Go client. It is currently, if we go to the GitHub for Pinecone.io, there is and let me go as, yeah, go Pinecone. Whether the gRPC, this one I actually don't know within the Go. Yes, it does contain the answer's right here. It does contain the basic gRPC bindings for all Pinecone vector plane operations for upsert, fetch, query, delete, and info. This would be the, as far as documentation on our main website, this would be the sum total of our documentation as it relates to the Go client here. Okay, so for whether Python is required, Python is not necessarily required. The main reason why we use the Python is that it's pretty relatively ubiquitous, and Jupyter notebooks are easy to kind of populate and run. However, we do have a couple other connectivity options that we are working on currently. The Python client is the actual officially supported client. However, we are working on some additional ones such as Spark and Java as well.
And we have, and of course, we have the REST API that people can use.
Oh yes, sorry. Yeah, definitely. And most customers do take heavy advantage of those REST clients. I mentioned earlier Postman, being able to run those types of things. You can script out those REST calls. You can use a variety of languages as long as they can make a REST call. So yeah, absolutely. Okay. So is there any way to make sure all vectors get upsorted successfully in an asynchronous fashion? Also, is there a way to identify missing vectors in the index? So Greg, do you want to take a swipe and I'll follow up on that one?
I'll pass it to Dave.
Yeah. I figure you're going to push it towards me. And yeah, happy to chime in. So I'm Dave Bergstein. I'm the head of product at Pinecone. And I know that I'm going to take the latter part of the question first. I know many of you have asked for the ability to get back all the IDs in an index, and know what you've upserted. And I am happy to say that we are hard at work on this. And we expect over the next quarter to have the ability that you could dump all the IDs into your blob storage. You could also have an option to dump all the IDs and all the vector values, all the metadata, pretty much anything you want into blob storage. And from there, you could, do anything you want with it. It would be in your blob storage, your S3 bucket or GCS. we do consider allowing this right from the index. Some of the concerns were that, many of our customers are very performance sensitive, and yeah, we are cautious about what functionality we include that could in any way potentially disrupt our performance. You can imagine long-running jobs where you want to get back all the vector IDs. But yeah, again, pleased to say that we'll have that soon as a dump to your S3 bucket or GCS bucket. I think I missed the first part of the question about the async, the ordering. I believe the question was about the ordering.
That's right. Is there any way to make sure all vectors get upserted successfully in an async fashion?
Yes. So, and maybe Kevin, we can always follow up, and I think maybe you might know better. Correct me that when you do the async upserts, there is a return message, and what you want to do is ensure that it's a 200, successful upsert. The upserts in each asynchronous call is all or nothing, and so yeah, you want to check for the 200 message. If it's not 200, then it didn't go, and if it is 200, they all made it. It's all or nothing. In terms of the order, once you start going to asynchronous, we ensure that as the calls are received by Pinecone, that they are added to our, we have a write-ahead log, and they're effectively added to the write-ahead log in the order that we receive them. But when you're doing things asynchronously, it's maybe not trivial or easy to know which order that we receive them in. So in respect, that's always a challenge. I don't know if that helps.
Okay. Appreciate that, Dave. So let's see. Okay, so from Gerald, when sending queries using the ID of the query vector, does the query vector need to be in the same namespace? So queries by themselves do require a namespace, even if it's blank, in order to specify that. So one thing that we talked about, or that we may not have talked about actually, was the idea of namespaces versus metadata and how the filtering happens on that. So when we query for an ID, and Dave, please correct me on anything I say but when we create a query and it's in the API call there, we specify the query, the ID, and depending on which API call you're talking about. So a fetch really only requires the ID, where a query requires a namespace.
And maybe I can add, I think I'll say maybe I don't know the answer, which is that, so originally we did allow you to reuse IDs in different namespaces. And so we have a way to basically disambiguate that. But when you query by ID, to be perfectly frank, I'm not sure how you would specify which namespace the query should occur in. And I know we have I should find out the behavior and we can follow up. It is interesting that this is something that we've debated internally, is that it may have been a wrong decision of Pinecone to allow different namespaces to reuse the same IDs. And if there's feedback on that, I'd love to hear it. It's something that we've considered that maybe we should have been, we maybe should have disallowed that. But yeah, would love to hear input.
So from how I understand the question, like it's not about what vectors we're returning, but what vector we're using to query. So does the query vector really have to be in the same namespace that you're querying? I don't think.
Oh, I see. Maybe I jumped into, I get the point. You're right. I think I'm just puzzled on, so if you don't reuse IDs, then it should work as Greg just said. It just takes the ID of the vector that you gave it, and it doesn't matter the namespace. However, unless you specify the namespace, in the query, or unless you specify a filter, as Kevin pointed out. And I'm pointing to maybe jumping the gun on an issue, which is that if you happen to have more than one ID, if you reuse the IDs, you can end up in a situation where it's ambiguous which ID you are referring to. That makes sense. For the query vector, right?
Okay. We missed one. There's one from Chad who asked for query performance or their non-REST API options, maybe because it's partially answered, but Kevin, is there anything to add to what you said before about about other clients?
Yeah, I think I may need a little more clarification when we say non-REST API. We use OpenAPI as that REST endpoint, and a variety of languages can, as long as it can make a REST API. But I'm curious if what we might mean by non-REST API options.
I'll take one from John, who a comment about the comparison of vector search with SQL-like. Yeah, John, you're far more experienced at this than I am, and so not surprised you found the fault with the analogy. It's just meant to be a basic analogy, like to give developers who have no exposure to vector search an idea that this is when you perform a vector search, it's something that resembles a fuzzy search more than an exact search in a relational database. You're not doing string matches basically. So probably someone can find a fault even in that explanation that I just gave, but I wouldn't be surprised.
So if I could just walk in with following up on my earlier comment, I got the answer from our engineering team, and the answer on the behavior when you have IDs that maybe wasn't even the question, but I'll say if you have IDs that are repeated within the space and you do a query by ID and you don't specify the namespace, we go to the default namespace. And so that would be the order that we would consider. If you give us just an ID, we always take the default namespace that ID would occur in. Just clarifying.
We have a few minutes left, so let's keep going. Sina asked, is it possible to combine Pinecone vector search with Elasticsearch?
Maybe I can speak to that. Yes, I would say that a number of our customers do. And what they do is they typically run their keyword search in Elastic, and they run a search in Pinecone, and then they combine the results. And there are a variety of different ways that people combine the results. And we would, certainly offline, we could, hear your case and share some input about how this is typically done. But yeah, it is something that is routinely done that, we recognize there's value to keyword search. We, of course, love vector search, but it doesn't mean you can't benefit from both. And again, great ways to combine those results.
And then Sina had a follow-up comment that it would be fantastic if there was a Pinecone plugin for Elasticsearch or OpenSearch. Interesting idea. Yeah.
Yeah, thank you.
John asked, I'm glad it's not a rebuttal of my previous statement, John. In terms of Pinecone's embedding models, do you provide defining what embedding models are used? Basically, setting up some sort of embedding pipeline in Pinecone. I can answer I can give a short answer, and the answer is no. We are agnostic to the model you use and what the embeddings represent. You just load your embeddings into Pinecone and we index them. We do not host the models and we don't perform the embedding for you. Although we recognize it would be useful for some people. Currently, we direct users to try one of the other options we mentioned at the beginning, either an embedding service like OpenAI's embedding API or Cohere's embedding API or Hugging Face sentence transformers. Even once you find the model, it is still on you to run it or host it somewhere. Gerald, I hope Gerald, yeah, clarified about the query by ID. Okay, we got through everything right on time. Oh, there was one more from the chat. Justin asked, how much RAM does every pod have, and can we scale vertically or only horizontally?
Maybe I could speak to that one. I guess what I want to say is first, it's not necessarily a clear relationship on the RAM. You know, we have some gigabytes of RAM per pod, but the truth is we use both SSD and RAM. And so either one can actually be the bottleneck in terms of storage. As for scaling horizontally or vertically, these are capabilities we're soon going to have. You know, we're looking at adding vertical scaling, and it will be without downtime. On the side of horizontal scaling, you know, in terms of safety right now, we're looking at the fact that you would have to stop, but we can make it quite easy to scale.
So yeah, that's coming soon. And today people will either over provision an index or when their index needs to grow beyond the pod capacity, they just create a new index and switch things over. For especially large indexes where re-ingesting all the data is going to take too long, you can reach out to customer support at pinecone.io, and we'll see what we can do to help you make the switch easier.
Yeah, and maybe just bubbling it up one. It's thinking about the question. It is our pods that are the horizontal scaling, right? When you add pods, or when you create an index with more pods, that is horizontal scaling. When you add replicas, that is horizontal scaling. And yeah, the vertical scaling is coming.
Yeah, and replicas, you could scale replicas today. I don't know that we talked much about replicas, but you can increase replicas to increase your throughput, although it will not affect your index capacity because you're just making copies of the same index. But that you can do today to handle spikes in traffic. Some customers even do it programmatically if the spikes are consistent. Great. Sophie, do you want to wrap it up?
Absolutely. Thank you all for being here and for your wonderful questions. Thank you, Kevin, Dave, and Greg for all of your wonderful insight on the answers to those questions. And as I mentioned, the recording, demo, and deck will be sent to you all later today. Have a great rest of your day, everyone, and thank you so much for being here.
Bye, everyone.
Thank you.